Hi there. Okay, I'm gonna open up screen share and let's get started. All right, so this talk will be about library heist or using libraries or code from other programming languages in Elixir or Erlang, or basically most of these methods should work for any Beam-based language. Uh, so, so yeah, why would you want to do that? So one of the reasons is performance. You can go lower level with for your computations with by using some language lower level language like C, C++, maybe some Rust, Zig. Um, next thing would be like code reuse. You can write code once in a single language, for example, not Rust, and then reuse it for a CLI app or for example, I think Rust can be ported to Android, for example. So you could technically write Rust code once and then use it for your JS code through Wasm, then use it on Android, and then use it as a library for your Elixir code. There's also this way you can have more libraries available. So by utilizing other libraries, you have much more libraries at your disposal. There's also a cross-platform aspect for this. So as I said, some languages can compile to Wasm, can work on Android, maybe iOS. Also, some languages can transpile to JS, so you could even use them on the front end. Okay, maybe I should have clicked those. Okay, so what are your options when using Elixir? One of the options, like the simplest one, would be to write a CLI tool first in another language, utilize that library there. So here's a simple Python program that just takes a single argument and then reverses the string that you pass through the CLI, and yeah, and here's a simple wrapper for that using system.cmd in Elixir. As you can see, it's pretty simple. You just this is the path to the script. You call the Python executable with the location script and your argument, which will be then reversed by the script. You also match on the exit code, so you know it passed or you didn't. So what are caveats of this approach? This IPC overhead, so basically when you're passing arguments or even starting the Python executable, this basically usually ends up you end up starting up a shell, so something like a bash, and then from this shell there are a bunch of commands that put in, for example, environment variables. And then Python is called, and then Python parses your file, and there's a bunch of stuff involved in that. Next thing would be that this is blocking. So when you call that Python function, your process is blocked until the function and this system, the CMD call ends. So if you have like an infinite loop in your Python code, your process is taken over until it's killed. You also have to rely on the CLI tools output format. So you can most tools support something like JSON. Maybe they return some plain text, maybe some binary. That really depends. But you have to probably write some extra code to basically communicate between the CLI and your Elixir application. This is all the latency aspect. So opening up Python program each time you want to run a function, those come with a cost in terms of latency. So I would not recommend if you need to like periodically every second call a function to use this approach. As I said before, you have to write some boilerplate for it. You have to write the CLI or utilize already existing one and write an adapter for it. So this is a common use case for this with FFmpeg, I think. many times you would just call fmpeg with system.cmd and pass the location of the file. That's a common way to use this. There's some issues with environments. So if you go back the slide, let's go back. As you can see, we're calling a Python. We don't really know what that Python is. Some Linux distributions have Python symlinked as Python 2, and some have as Python 3. So you don't really know what the Python is. So that's one of the issues with that. So you don't really know what you're calling, and you have to have full control over the environment. All right. So let's go to the next approach. Next approach would be like writing using a TCP or HTTP, basically a microservices approach. So you basically take your I don't know, Rust, Go, or any other language app, and then write a REST API or GraphQL or gRPC for it, and then communicate using Elixir, some sort of a client for this. So what are the caveats? Network overhead, of course. It shouldn't be that much for most cases. There's a complexity aspect, so you have to think about deploying two servers, your Elixir server, as well as your Go or Rust server. That could be annoying, but that could also be good depending on your engineering team. So maybe you have some Golang developers, and some Elixir developers. You could make each of them make their own thing. So that could be actually advantageous. There's additional boilerplate. So for gRPC, you have to write protobufs. For REST APIs, you have to think how the JSON is designed. For GraphQL, you have to deal with GraphQL files. There's also latency. So when going through network, you have to take in account the latency of this. If you're running in localhost, it usually isn't that bad. So as I said, complexity of deployment. All right, let's go to the next thing. After this, another option would be writing NIFs. So what are NIFs? NIFs are basically a way to call C functions from Erlang, Elixir. Yeah, but not exactly. You can basically call any language that supports CFFI, so foreign function interfaces, which is basically almost every language that really compiles to anything. Even I think even Java can export CFFI. So if it has a CFFI, you can use it as a NIF. Also with C being the top systems programming language, like I don't think that there will be many languages that don't have it. Okay, so this code I'm showing here is some boilerplate code from a personal project of mine. As you can see, this is the Elixir part. I'm using a library called Rustler, which this part is a macro that will inject the NIF, and this is a stub, which basically will be replaced by the native function on runtime. It might actually matter for you that this is not. You have to remember that this is not replaced at compile time, but runtime. So yeah, but it should be fast enough that you don't really run into an issue that it's not loaded before you call it. And this is a part in Rust, but it basically you just have to put a macro above your function, Rust NIF macro, and you can basically just write Rust as usual. You don't really have to do much at all. And then you have to also export the function by telling which module this is exported to. Which one important thing to remember is that Elixir modules, when called from the Erlang word, are prefixed by Elixir dot. which might not be obvious if you never used called Elixir from Erlang. All right. There's also an issue with this code, which you might notice when I read the excerpt from the Erlang docs about NIFs, which is actually one of the better explanations I found about when to use NIFs and what they are. So I'm gonna jump to that, and if you can find please type in the chat. Maybe you find it before I explain what's the issue with this code. All right. So NIF, native implemented functions, are a simpler and more efficient way of calling C code than using port drivers. So they say C code, but as I said, you can use any language that uses CFFIs. NIFs are most suitable for synchronous functions that are relatively short calculations without side effects. So yeah, you have to keep that in mind, that it's not really that suited for doing asynchronous things, but of course you can use the vast power of Erlang and Elixir to make them asynchronous, I guess. An if is a function that's implemented in C instead of Erlang. NIFs appear as any other functions to the callers. They belong to a module and they're called like any other Erlang functions. The NIFs of a module are compiled and linked into a dynamic loadable shared library. So you're probably familiar with SO files or DLL files for Windows. So basically, when you package the app, you should get an .so and .dll file alongside it and package your Elixir app with this. The NIF library also must be loaded at runtime by the Erlang code of the module. So in this case, this macro is actually running the necessary code to load the NIF during runtime. Okay, this is going to be very important. As a NIF library is dynamically linked to the emulator process, the fastest way of calling C code from Erlang. So this is basically your fastest way of calling this or calling C code, if that's what you're looking for. Calling NIFs requires no context switches, but this is very important. It's also the least safe option, because a crash in a NIF brings the entire VM down. So that's pretty bad. If your code is not like perfect, that's pretty bad. But for example, Rustler, the library I showed off, those have some guarantees that it won't crash your process in 99% of scenarios. So that's not that bad, but it's pretty bad. All right, let's go back here and I'll explain what's the issue here. Okay, this code, this part actually makes a HTTP request, and this is not a good idea, because HTTP requests can get really faulty at times, and they also take a long time. So it's not really a short function, and it doesn't really do short calculations, and it has side effects in terms of making HTTP calls. So that was the issue of the code. Now, what are some good libraries for utilizing NIFs in Elixir? Here I would recommend for Rustler, really great library. I actually used it quite a lot. For Zig, I'm not much of a Zig programmer, but this library seems pretty good for Ziggler. For C++, what I found is Unifex. It's a part of Membrane Framework. It's a very interesting project. I recommend you to check it out. We'll also go back to this later down the line, because it also has some other cool feature. And there's also while making this presentation, actually find a pretty interesting project called Exile. It's actually we're gonna go to ports next, but it's a great alternative for it that's implemented in NIFs. So you also might check this out after hearing about ports. Okay, next way of dealing with external programs utilizing libraries would be like ports. So here's a Here's a graph I stole from Erlang documentation that shows how it works. So basically, you spawn a process, which would be your C application or Rust application. Spawn this, and then this process is connected through a port, which is part of Erlang. And then this port basically translates commands from this external program into your Elixir application or Erlang application. So looks pretty simple, but there are some issues with that. Here's a example for like calling Python from Erlang, but the code for Elixir would be very similar. Just basically just replace it's okay with an atom, so a colon here, and should be pretty much similar. Which annoying part is would be like that you have to address Python modules as atoms, not as strings. So yeah, that's kind of annoying. But as you can see, you can this basically spawns a Python shell and then returns a PID of the port, and then you can call this port with the Python module name as an atom, and then the path to the function, and then your arguments are here. And as you can see, it would return a char list. Unfortunately, char list, that's one of the issues with the airport library, that doesn't support binaries, but returns the char list, so you have to deal with that. And another thing is that you have to stop the process manually. And I'll also go back to this next. This might become an issue. All right, so for this approach, you need to wrap your code in some port glue in Python. So airport has a Python library that you have to use in order to return values from your functions to Elixir. Which also is a big caveat, because your programming language needs to have a port library for you to even interact with it. And those libraries aren't really that common. Like Airport is probably the only one I really found in a usable state. And Airport does support Python and Ruby. That's pretty good for Python, I can say. I don't know about Ruby though. Okay, so this is what I said. Okay, that's another problem with this. You have to handle when the spawn process crashes or has memory leaks, and also if you crash your port and you lose the reference to the process, you might end up with zombie processes that just sit in your system and eat memory for no reason. So that might be pretty bad. Here are some libraries I recommend. So it's basically Airport for Python and Ruby. There's also a Venomous library that wraps Airport for Elixir and easier usage. So that I would also recommend for Python. Okay, the last thing I'm gonna show you from for the presentation about for actually calling the code are C nodes, which is the most complex way of doing it. So here's some AI generated graph. It's kind of okay from what I looked at the documentation. It's really complex because how this works is basically your external program has to pretend it's an Erlang node. So you basically have to implement a part of Erlang in your language, which is terrible if there's no library for it. That's a first. And second, there's a lot of complexity with it. If you don't really know much about Erlang nodes, and if there's a bug with the library, you will be lost. But the Erlang does provide a basic C library called EI. It's pretty well documented in the Erlang docs. You can check it out, but it is quite complex if you're not used to low-level C stuff and you're not familiar with the Erlang architecture. So I would not recommend that unless you really know what you're doing and you have, or you just want to have fun doing low-level stuff with Erlang. Another thing would be the Unifex that I also talked about in the NIF part. Unifex actually has a very interesting feature that you can write your C or C++ code once, and then the same code may be used as a NIF or as a C node. So that's very interesting. I haven't really tried it, but I think it works because the membrane project seems to be in a good state. So I would recommend checking that out. For Rust, I found something like something called Eldist. I don't know if it really works that well, but it seemed interesting. So you might also want to check this out for Rust. For other languages, I didn't really find that much. Maybe there was, I think there was some Go library, but I don't know much about Go, so I didn't want to bring it up here. You might find some stuff for Go, yeah. And that's it for the libraries. And that's it for the tooling part. So where do we find libraries? A very good way to find libraries is to just type into a search engine like Google, type awesome and then your language name. You're probably gonna find something like this, which is a Git repo, and then there's a table of contents, and it's split into different categories. So you can find a bunch of great libraries through that. And yeah, and this is it for my presentation. We can move to the Q&A part, I think. Okay, maybe I'll start the Q&A.
Thank you very much for your presentation. I see some very positive feedback in the chat, so that's what we love. This was a great one, and now, as Max said, we invite you all to ask questions in the Q&A session.
Okay.
So Gaurav is asking, I am concerned about the overhead. How much more according to the different languages used for different functions?
All right, that really depends which method you would pick. So like the basic like system.cmd method, if you're passing a huge, let's say like a gigabyte of binary data, for it, it's gonna be terrible because you're gonna need to allocate twice as much, at least twice as much. So if you want to pass 1 gigabyte of binary data, you would need like at least 2 gigabytes of RAM for it, which is very wasteful. But for Rust NIF, you can use any NIF, actually. Any NIF, you can just pass a reference to memory allocated from Erlang, and you basically don't waste any memory. So there's almost no overhead for that. For the Erlang nodes, C nodes, there's a bunch of overhead because you also need to basically run an application which simulates the Erlang distribution layer. But this might come at a cost, but it is, which you can see from the memory framework, is very good for asynchronous calls. So NIFs are mostly for like synchronous stuff. And if you need really performance for asynchronous stuff, C nodes are great for it.
Thank you for your answer. We have words of praise from Santosh. That was nice. Had used microservice built with other language. We'll try this new approach. Thanks for that. Yeah, and yeah, we're waiting for some more questions from you guys. If there are any additional ones, we have a bit of time for this. So yeah, if you have any specific questions to the speaker, this is a good moment to ask them. Right, another question from Gaurav. Let me just pin this in the middle. Is there any reset of NIFs done when we using Gen servers and our program crashes?
All right. If you mean by program crashes, you don't mean the Elixir or Erlang part, or you mean the NIF. You're basically, if your NIF crashes, you are done. It will bring everything down. So basically, you have to, and from the NIF side, you have to ensure that it doesn't panic, doesn't do any panics or how is it the C call segmentation faults. Oh, it doesn't segfault. So you have to do that from the program side, so it doesn't segfault, doesn't panic, and then you're relatively safe. As I said, the Raster library does include a good wrapper for this that will prevent 99% of cases of crashing. But if you would connect like a basic C program, I would segfault. It basically will bring everything down. So you really have to know what you're doing with that.
Yeah, and follow up on this. Is it just the connection reset or the whole cycle? I mean, do we lose the data retrieved in that case too?
Uh, Not sure what you mean by that connection reset. Because if Erlang VM basically runs on top of everything, so if you bring it down, you're losing everything basically, unless some DB is involved in between.
Right. Thank you very much for your answers to those. And we have a question from Tariq Demirci. If we go back to the FFmpeg example, would you prefer a CMD call or a NIF approach?
Okay, for FFmpeg, I would actually just use system CMD. It's mostly the most preferred approach. If you actually looked at GitHub and type in some FFmpeg and look for code, most of the people are actually using this way because FFmpeg CLI is very robust and has a lot of options. Basically it's a programming language and a library in itself. So yeah, and you also don't really pass any data to it. You just pass the options, which don't really take that much characters, and then you pass path to the file, uh, and then FFmpeg basically you either writes to another file or modifies the current file depending on how you set it up. So for FFmpeg, I would just use system CMD and then run it asynchronously so you get and then wait for it to finish.
Right. Thank you very much for your answer. And we have another question from Ahmed. Does the Erlang observer show any metrics about NIFs being used in the system?
I actually have not tested that, but from the Erlang perspective, the NIF, once it's loaded, it doesn't have any extra metadata. It just looks like a native function, like the name suggests. There's no it's not really distinguished from regular Erlang functions. So if you can do that with regular functions, you can also do it with NIFs.
All right, great. Thank you for your answer. Is there anyone else who would like to ask any questions to the speaker? If there are no further questions, you can continue. You can reach out to Max on social media to ask further questions to him after the presentation. Once it's uploaded to YouTube, you can also comment on that there. So we encourage you to watch this again if you found it interesting and you would like to revisit it. We have one more question from Ahmed. Any major improvements you've seen in your own project using NIFs? Biggest performance improvement you've seen?
Okay, that's a bad question for me because I mostly use NIFs to have some fun with Rust. I didn't really make it for performance reasons. So yeah, as you can see from the example I showed with the issue with it, I was just too lazy to to call to make HTTP request from Elixir and then pass this to Rust. I just I just made a HTTP request from Rust, which is not really a good idea for a NIF. But yeah, if you're calling improvements, the improvement was I was more eager to work on my own project because I was excited to test this feature out. But if you're looking for performance, I encourage you to check out the membrane project because they're really focused on that to get the maximum performance out of NIFs and C nodes. So I'll even post a link to that, I guess. Give me a second. Right. Hopefully there's no filter for links. Okay. Okay, so I encourage checking that project out for if you want to learn some stuff about performance.
Right. Thank you for your answer on this. I guess if there are no further questions, then this concludes the meeting. But there is another one, and we are going to show this to Max so he can answer again. So I understand that Elixir Airline is very good at something like multi-point electric socket, which ultimately connects to the main supply line. Is it understanding correct?
I think that actually makes sense. Yeah, because main point of using Erlang is that you can spawn a bunch of really small form-factor VMs, which basically still are managed by the entire virtual machine. So I think that might be correct because it ultimately everything goes back to the main VM.
Yeah, it depends on the infrastructure and the architecture you want to achieve, but in a way, this is right. This can be done, so that's a feasible one, I would say. Good. Thank you very much for being with us today, guys. And thank you very much, Max, for having this great presentation for us tonight. This has been a pleasure to have you as our speaker in this meetup. So what next? Obviously, in a month we are going to host yet another edition of the meetup, number 34. We of course invite you to sign up to be an attendee in the next one or become a speaker in one of the next ones. And this time that's it for today. So thank you very much for being with us. And if you don't mind, please do stay just for a few more minutes to complete a survey about the meetup as well as a feedback to the speaker. Thank you very much. Goodbye.
Have a nice day.